Assalamualaikum warahmatullahi wabarakatuh. So insyaAllah this will be our last video regarding chapter number 3, standing wave. Okay, now, so for today version, what we will do is, number one, we will revisit how to derive the expression. However, you must remember that the derivation is not a must. It's just that I meant to expose you the technique. Alright, that's number one. Number two, we are going to look at the resonance now on string. Not on string. We have done that yesterday, but on air column. And finally, we are going to look at what we call as beat phenomenon. Alright, let's first turn to the textbook. Okay, the textbook is on page 454. 454. Alright. Now, basically, there are two expressions that I showed you yesterday that I asked you to take note but not derive. So today I'm going to show and help you in how to derive. Alright. So yesterday we learned that when object under the concept, wave undergoes interference, okay, so the net product of those two is it will be amplified or disruptive or constructive. In the case of two wave here, where the first wave is A sine kx minus omega t and the other is as given in the purple color, when they are added, they will look something like this. So we are going to use trigonometric identity, which would be if sine plus sine, then we are going to get 2 cos A minus B, which is this one. 2 cos A minus B divided by 2 sin A plus B divided by 2. Alright, let's start with A minus B. Okay, now A minus B, A just now, from the first expression in the bracket belonging to the sign just now will be kx minus omega t, while sign will be, for b, kx minus omega t plus 5. So since it's minus, it shows that they both travel in the same direction. It's just that they differ. Differ maksudnya tak really overlap with one another with another phase constant. So probable like this, okay? Now, when that exactly happen, okay, so we find that when we do minus, k minus kx cancel out, negative omega t minus negative omega t as well cancel out. That leaves us only negative 5. While a plus b will give us 2kx plus kx, 2kx, omega t, negative 2 omega t, and plus 5. Alright. So by substituting this product, let me reduce the size. Okay, I'm now going to use perhaps K color. Alright, green, purple color. Alright. To reduce. Okay, that's nice. Alright. Now, therefore, A minus B turns out to be negative 5, while A plus B just now turned to be 2kx minus 2 omega t, 2kx minus 2 omega t plus 5. Plus 5. Now, so I'm going to introduce another color. So this is number 2 just now. Okay, so let's divide 2, divide by 2, and then divide by 2. 2k become kx minus now omega t. So look at here, 5 over 2, clear? Alright, regarding this one, you just add, there was this another identity, where the identity says that if you have cos theta, then this cos theta is also equivalent to negative cos theta. So that's the reason why the negative here disappear. It disappear because they are just the same. You can just go with your calculator, give it a try. Cos pi and then cos negative pi, or cos 3 and cos negative 3. So you should arrive with the same value, same value. Okay, now do you understand how do we get this expression? On the other hand, something to ponder. So since we have variation of times over here, over sin, okay, over sin product. So it means that this product of 2a cos 5 over 2 is actually the resultant amplitude. The resultant amplitude due to the interference. So if the question is asking, calculate the amplitude, then this is the product. The 2a from the two experiment, the two value just now, a plus from the other expression, okay? All right, let's look at the next one. Okay, page 456. Right, page 426, equation 17.1. This equation is meant for standing wave, resonant. In the case where you have resonant, most of the time, wave supposedly is coherent. When they are coherent, they have the same phase, they have the same wavelength, except that usually they are traveling towards one another. So that's the reason why you see Y1 here, the direction is to the right, negative, while Y2 is directed to the left. Okay, so they are traveling toward one another and then add up. Okay, so the resultant wave function will look something like this: Y1 plus Y2, A sine K, something similar to the previous. All right, so when we do a little bit of mathematics, A minus B divided by 2 will turns out to be Kx minus Kx, cancel out. So let me use my highlighter so that you can see. Kx minus Kx, none, nada. Negative omega t plus omega negative omega t, then you have negative 2 omega t. And due to the fact is we can cancel out, okay? The 2, and as well that, remember earlier, cos theta is also equivalent to the cos negative theta. So we just take out this negative because it might confuse us. Okay. Now while sine theta, A plus B, you will find that kx minus kx omega t. So simplify, you have 2kx. Okay. And here goes the 2 can be cancelled out. So sin kx. All right. Now here is something a bit different. Okay, let's double check with the previous one. The previous one have cos put in front, rearrange in front. Okay. While this one, it was sine that rearranged in front. Okay. Now, so let me clarify you. This is actually net amplitude. When I use term net, represent the overall, the hasil tambah. While this is the function of t, cos omega t is function of t. Understand? So that's the reason the expression is as such. Now, from my past experience, I haven't seen yet that you were asked to derive, but perhaps you have the need to understand. So that's the reason why I am sharing you. All right, let's have a look at resonance, standing wave on a string. I know this is repetitive, but I like to go over so that you can understand and appreciate what's going on. So in our previous session, yesterday, the understanding is that overall resonance harmonic series for on a string would be n over 2l tension over mu. Okay, square root tension over mu, where this expression is as well equivalent to n over 2l times with the V. So this tension over mu is the product of V, speed of string on the speed of string. Okay. Right, let's have a look. Okay, from yesterday, what I did is that I rearranged all the expression as F equivalent to V over lambda, and I identify the lambda. So according to this figure, the lambda must be, okay, the lambda must be twice the length of the string. Twice the length of the string. 2 cups. So you only see 1 cup saja. So that's the reason why the lambda is now 2L. Now, so as you observe, this is F1, first harmonic or fundamental. This is second harmonic, or sometimes we call it first overtone. First overtone, okay, but probably would not be used in this textbook. Right, second, because we have 2 segments here, 2 loops here. Okay, so, and recall yesterday as well, the part where keep vibrating to the maximum is called anti-note. The one does not move is called notes, right? So how many lambda do you observe here? It's just a single lambda. So one single lambda here, and the single lambda is as well equivalent to the length just now. Let's look at the third one. How many lambda do you observe? I find that I have 1 lambda over here, and I have another partial lambda over here, incomplete lambda. So therefore, this is actually how many lambda? 3, 1.5, 1.5, 1.5, 1.5. Hold on. 1 lambda, 1.5 you are seeing 1, okay. Lambda, all right. So you are seeing 1.5 lambda. Okay, lambda is 1.5. Okay, I am stumbling. Okay, hold on. 2/3 lambda. Okay, let me write it down. Length is now equivalent to how many lambda over here? It's 1.5. This is 1.5 lambda. All right, okay, correct. How many lambda that we observe in this figure is actually 1.5. Okay. How many lambda? Lambda is actually overall throughout the whole string, I have 1.5 lambda. And how many lambda? All right. Therefore, this 1.5 lambda is also equivalent to 3/2 lambda observed in the whole string, the whole length. And therefore, so simplifying it, you will find that L, the lambda that you observe in this picture becomes 2L over 3. Okay, 2L over 3. Right. Let me rub this. Okay. So I am going to replace this into here. Okay, into here. And due to the fact when I rearrange, I will have something that looks something like this. V over 2L over 3. So 3V over 2L. Now, let's see something. Over 2L. Over 2L. So I am now modifying this expression so that it's also over 2L. Since I am modifying, I'm going to use this color, green color. So 2, and therefore here 2. Now, what do you see as a pattern? You see number 1 is divided with over 2L. over to L, I can go to 4 harmonic, 5th harmonic. You will still arrive with over to L. And I can see as well that this is number 2, represents 2nd harmonic. This is number 3, 3rd harmonic. And hence it makes sense that this is 1. So in short, I can now generalize it to become an expression where 1, 2, 3 will be replaced with N. 2L is a constant that I just put down here so that I can just replace any number of length. And then the V. And the next level would be putting in the value of V just now of this expression, because this is on a string, Understand, hopefully. All right. Now, today version, okay, this is where we are going. So, we are going to look at resonance in air tube and as well resonance in, not resonance, what we call as beat. Okay, what we call as beat. All right, let's have a look at resonance in air tube. Standing wave in air column. So I am now page 466. All right. Let's first understand the idea of notes and anti-notes. Okay. All right. I am now leaving the other page, 467 now. Okay, number 1, we have 2 types. Number 1 is both is open so that air can travel. So there will be air traveling inside. So that's why we have speed of sound, or sound can travel in. Okay. Number 2 is one side will be closed. So you are looking on the left side, there's one as open, while this one is open, close. So this is closed at one end and then open at the other end. So this is open at both ends. Okay. Now, whenever it is open, you will find that at that location, the air are free to vibrate. Since air is free to vibrate, therefore, it will be, we tend to draw it as anti-knot. Okay, anti-knot. Now, however, okay, it's quite opposite to what happening to the air or pressure inside it. Okay, pressure inside it. We find that pressure at the nodes is at the antinodes. Okay, at the antinodes. It means that the pressure is maximum at that location. If I can draw dotted point to let you understand what really happened at this location. So this is how it looks like. And this is how it looks like at the location opening, where air is free to rotate and there are room for movement. So since pressure is high here, so let's jot down, pressure is high here because all the particles are compressed at that very close position. Okay, very close position. So for the pressure, it was a bit different. But for the understanding regarding whether antinode or not in terms of our sketches, okay, this is on the left side. Okay, this is on the left side. All right, so displacement. So remember, not remember, something to look and jot down. So this is in terms of displacement of air particle. Okay, displacement of air particle. While this one is pressure experienced by the air particle. Okay, now coming back. Okay, so in terms of technique, how to draw, okay, very simple. So this is at the maximum amplitude. So I'm putting dot here across so that you can understand. And then here, so just get it connected. get it connected. All right. Okay. What do you see just now is actually almost like one segment, but being cut open and then inverted. Terbalikkan mereka. Now, the second harmonic, we did the same thing. At the opening must be amplitude. Okay. Earlier, there was just a single note. Now, there are two notes. 1, 2. So, connect them together. You are going to get what we call as second harmonic. Now, in the second harmonic, observe as well that you have two segments. Let me sketch it. This is one, and this is the other two. When you combine the shaded area just now, you have two segments. Okay, two segments. Now, since this is one segment, one loop, okay, one loop, you will find that it has very similar shape as previous one, which is F and V over 2L. Which one? Belonging to the string. Sorry. Belonging to the string. That's one. A segment. A loops. Get back to the book. Alright. Let's test our understanding on the next one. Third harmonic. So at the opening, maximum. So I'm putting dot here, green dot here. Now it turns out to be 3 antinodes. Then get them connected. So as simple as that. Okay, as simple as that. So in the final, is it possible to ask sketch? Yes, they might ask. Okay. All right. Now, in conclusion for the open, this is open, you will find that the resonance will have the similar equation as string that are fixed at each end. Okay? So string, if you remember earlier, at the fixed end must be notes. Reason, because when wave send there, it get reflected and the shape at the end will resemble as if there is no amplitude, and we call that position as note. All right. Okay, so here we have notes, okay, as label. So N and then N and then N, okay, to the left, 3 notes, okay. So in terms of the numbering of notes will be a little bit different. Yeah? For this second harmonic, there was 1, 2, 3 notes. But for this one, there are only 2 notes. But it's much easier to understand in terms of drawing for a column, okay. Okay, now, how about V? Okay, how about V? Since we are talking about sound, therefore this V is actually speed of sound. Okay, speed of sound. 331 square root 1 plus something. T divided by 273. Let's go over there later. All right, how about if it's close at one end? All right, every time it's close, every time it's at the fixed end, hujung, ikat, then the wave will be reflected back. Remember the concept of reflection? So it does has similar behavior as the sound because this is fixed end, therefore notes, right? It gets reflected in the opposite direction, inverted. It goes from this side and then goes down. So opening, always amplitude. Opening, always amplitude. Opening, always amplitude. Okay, so far so good. Right. Now, so the drawing will be as this. And this is something which is 1/4 of a cycle. Hold on, let it be. Okay, let's just learn how to draw. So the note just now increase to 2 notes. Here is also 2 notes. 2 notes, okay? And then the next one increase to 3 notes, right? Now that you know how many notes, you can now create the picture and have the pattern. Have the pattern. Learn how to draw the pattern. Have the pattern. Alright. Okay, now something weird for this one. Let me go to my sketch. Okay, for this one, you will find that the resultant frequency after this is n divide, oh, okay. Wait, sometimes it's not n, something m. So your book is using m or n to L, m. Okay, so your book is using m. Okay, m over 4L. Okay, and v. Okay, now, however, m is 1, 3, 5, 7, 9, 11, all the odds multiple, all the odd multiple. Let's have a look. How did we arrive there? Okay, this one might be a little bit unsure. How does it look like? Let me troubleshoot with this figure. Okay, Shopee. All right. What did you see? That this one is actually a quarter. A quarter of lambda. So the length here is actually just 1/4 of lambda. 1/4 of a lambda. Understand? So since this is a quarter of lambda, it means that the lambda is equivalent to 4L. The lambda is equivalent to 4L. Okay, understand? Eh? 4 times L become a lambda. Satu wavelength. While here, how many quarter did you see? I see the whole length has 3. 1, 2, 3. 1, 2, 3. So the whole length has 3 over 4 quarter of a lambda. Let me put it into here. 3 over 4. Sorry. Because this is lambda. Green. So 4 times L, 4L, but divided with 3. Okay. How about this one? Okay. You are now an expert. How many you see? 1, 2, 3, 4, 5. So 5 quarter. So the whole length in this figure is 5 over 4 lambda. And because of that, lambda is now 4L over 5. Now, simplifying the whole expression, I will arrive with 3V over 4L. I will arrive with 5V over 4L. While this one is just 1V over 4L. So let's just 1, 3, 5 is the M. Divide by 4L, every one of them is divided with 4L times the V. Okay, times the V. So that's kind of how it works for A column. All right, looking at your textbook, okay, to wrap up so that you can see where is the expression, madam. Okay, turn to page 467. So on open-ended, okay, open ends, okay, natural frequency harmonic series is NV over 2L. N is 1, 2, 3, 4, 5, 6, 7, 8. So if number 1 is 30, then number 2 is 60. Last one. Times them. Number 4 is 4. 4 times 30, 120. So it's a multiplication of the first fundamental. That's the reason why it called as series. Series, frequency series. Series, okay, harmonic series. While when it is open, only one and the other is closed, it should be, all right, MV over 4L. You can remember in this version or you can choose to remember all, okay? 2n minus 1, but it's quite famous using this one, MV over 4L. But you need to understand that it only exists in odd harmonic, So let's say for a question, 330 hertz for pipe that has this category, satu open, one close. 30 hertz, first harmonic is heard, but at 60 hertz, no. 60 hertz tak ada sound will coming out. Okay. Madam, how does the sounds of this resonance? Okay, the sounds of this resonance. Okay, I'll share with you later in because I just identify that whatever I present using YouTube's in this can't be heard by you. So no. Okay, let's try to answer this question. Quick quiz 17.4 to check our understanding. Now we have a pipe here that open at both ends. Open both ends and then it says resonates at frequency here. And then when one end is covered, okay, and the pipe is made again to resonate, the fundamental of this F close. Okay, which of the following expression describe how these two resonant? Okay, I'm gonna give you this as a homework. Okay, because you will find something. Okay, give it a try, yeah. Give it a try. Give it a try. Or will we like to? Okay, let's just. Okay, no problem. This is homework. Okay, quick quiz. Alright, example 17.5, wind in culvert. Okay, what is culvert? Culvert is a drainage. Let's have a look. What is culvert? This is culvert. Okay. Just sharing you stories. Ever heard that about ghost town, especially in old movies, English old movies, and you find that in the movie there will be howling sound, something like that. Back then when we are at Kuantan, when our campus, CFS campus is at Kuantan, there was this particular building where the air tend to enter the building, our class, and making this howling sound. So we are in real experience the howling sound while we have the class. Okay. Why? Because the wind is the area is quite near. Kuantan is very near to, like 15 minutes to the beach. So it's quite windy in the evening. So the wind has enough strength to oscillate the air particles and creates resonance in the class. So coming back the example just now, so the whole story of this town is because of this concept resonance. Okay, this example is very simple. So we have to identify the ends. Okay, it says that it's open both ends to with S here. So open both ends. So since it's open both ends, so we are looking at over to L, V over to L. Determine the first three harmonic. So F1, F2, F3. Okay, where if you consider that V speed of sound is 343 and the length is just 1.3. Look at how length is substitute. Okay, so the length and here, okay, and the speed of sound is 343, 139. Now 139 times 2, you're supposed to get 279. 139 times 3, you are going to get 418. Okay, all right. So they are not repeating the expression. Okay, example 17.6. Simple apparatus for demonstrating resonance in air column is depicted in the figure. Okay, so at this end is closed. So this is open. So one open, one closed. Now a tuning fork is used to vibrate the air inside. And then the length of air column can be adjusted by moving the pipe up and down. Okay. The sound wave generated by the fork are reinforced when L correspond to the resonant frequency. So it was saying that the vibrating resonance, okay, how to put it, if it's just the tuning fork, then perhaps you just hear like ting, something like that. But the moment it match with the shape of the length itself, okay, if you manage to get the right length, then you will find that the sound would be like getting amplified. So ting, ting, a bit harder. So it sounds something like that, okay? So the question says, if the smallest L is 9 centimeter, what will be the tuning fork frequency? So the smallest represent number 1 and V over 4L. So substitute, you get 953, 900. So the moment it asks for the next two resonance, this is the trap question. You might have a tendency to just times 2. So what's supposed to be happening is 900, 900. Oh, so the next two resonance, yeah? Okay. All right. So if it's asking you the next frequency, no. We can't do that because we are only using one tuning fork only. So we can't unless it just says that what are the next two resonance frequency possible using this air tube, then only then you could get it by 953 times 3 times 5. Okay. However, the question is asking the value of the length. Okay. Now, value of the length here is actually 3 lambda. Remember earlier, how do I get this one? Okay. Hold on. This one. The next one is lambda becomes 4L over 3. 4L over 3. So what we did earlier, we are going to do this here. So drawing a little bit might be helpful. Ya? Kata tak boleh nak catch up this soalan. So the drawing most probable will look something like this. Two notes, remember? Okay, it's ugly. Right, so notes. So does this belong to the third one? Okay, all right. No, it's not. Let's double check. One, two. Okay, 1, 2. 3 is third. So that's the reason why I mentioned that you might get confused. So there was just one segment and a half. Okay, let's have a look. So this one is actually belonging to this one. All right, according to this figure, okay, how many lambda do you observe? Remember earlier, 1/4, 2/4, 3/4, 5/4? 1, 2, 3, 4, 5. So 5/4. So you see that the whole length has 5 over 4 lambda. So now what you need to do is similar to what they did just now. From the first value, they gather what will be the lambda, and from the lambda, they substitute here. Okay, 5, 4. All right, same goes with 3 lambda. Just again, draw with me. How many nodes? 2 nodes. Where is the nodes? 1, 2. This, let me use different color so that you can distinguish. 1 nodes, 2 nodes. All right. Okay. So how many lambda do you observe? 1/4, 2/4, 3/4. So 3 over 4 lambda for the whole length. All right. Okay, we have the figure, however, you can use that. but I need you to learn how to draw as well. Okay, we are on our last one version. 17.7 bits interference in time. Okay, before that, let's cross check this one. Okay, we have done analysis. So resonance, earlier today's session is more on the resonance with a column, and now interference in time, which is bit. Now bit is a phenomenon. What phenomenon? When two frequency differ slightly, slight different frequency sound simultaneously. Dua bunyi, frekuensi hampir sama, berbunyi serentak. Nanti you akan dengar beat. Beat in Malay, beat will sound louder than the ordinary frequency. Okay, hold on. Yeah. Okay, this is not as important. Okay, remember that this is not. Okay, this is the one that you need to take into consideration, bit frequency. What is bit? Bit is the differences of these two frequency when they overlap. Okay, so likewise what you see here, two frequency, two sounds that varied only slight frequency, slightly different. Sikit je beza dia. Okay, dia tak boleh beza banyak. And then when they overlap, undergoes interference, you see pattern to the sound. Okay. Oh, here is where total amplified, and then total amplified at this location. And here, total notes. So as if you again see a resonant, as if, but it's not a resonant. Okay. Now, mathematically, let's say that you have 442 and 438. So if they are vibrated together, so the bit will be 442 minus 438, 4. Understand? Or 438 minus 442. So 4. So the listener in within 1 second will be hearing something louder 4 times. Okay, 4 times. All right. Okay. Since I can't share this because the sound does not it's not there. Okay, so I'm gonna share it by using my handphone. Okay, what you are hearing is when there is no beat. So play tau, there was just sound like ghostly, kan? Okay, right. Now he is changing the left end. Right. Okay, let me go over again. Okay. The time is 0.22. Hold on, it's not synchro. Okay. The first one that you hear just now, that is no beat, the same frequency. Okay. Now this person will simultaneously. Okay, that's not. All right, listen. So, mine is. Okay, sorry that the sound does not synchro, but hopefully you can hear difference in terms of the sound just now, you tend to hear as if another repetitive. So that is what we call as beat. It gets slightly higher and as such. However, okay, for your class task later, I'll give you another video tuning a guitar using beat. You are to listen to this and you are going to answer 2 questions. All right. Okay, let's have a look at the book itself. Okay, this is our last example. Double check with the textbook. 17.7, yeah? 17.7. What I have here is lesson content, course outline. Okay, 2 identical piano string of length 0.75, each tuned exactly to 440. Tension in the string is then one of it is increased by 1%. Tension increased by 1%. So 1% here, it means that the first one is 100 plus 1, then it becomes 101. But since it's a percent, then you divide it with 100. It means that changes is now increased by a factor of 1.01. If they are now struck, what will be their beat frequency between these 2 strings? Okay, so beat is supposedly get the 2 frequency minus them. Okay, the original is 440. So the original is here. So we have the data. But what will be the new one? This one is how to get it. Okay, how to get it. Now what we did is we are going to divide the 2 expression. Why? Because they have quite similarity. You can use to get mu, to get the tension, but you will find yourself stuck because you have 3 unknown. Number 1, you are unsure to use the speed of this string, the length of the string, they have the same mu coefficient, linear mass density. So there's this tendency for you to get lost along the way. So what you can do is you divide the equation of frequency. Remember that frequency is V over 2L. So since it's the same length, okay, so the 2L can be now cancelled out. So leaving only V divided by V. Okay, V divided by V. And V alone is tension over square root mu. So as such, and remember that their mu is similar. So this expression is actually something like this. Square root mu divided by square root mu of the first 1 and 2. But they are of the same value. So that's the reason why they are to be cancelled out, leaving only tension divided by tension square root. So let's now introduce the number. So 1.01, 2 is increased. So 2 now is increased by 1.01 of the first T1. So now you can cancel out T1. And from there, F2 over F1 is 1.005. So F2 times with F1 440, 442. So 442 minus 440, 2 Hz. Okay, so you are going to hear the beat within 1 second twice. Alright, anak-anak, guys, that's it for our session today. Look at GC description on the homework. Thank you very much for your effort. May Allah always bless you guys. Assalamualaikum warahmatullahi wabarakatuh.